each of the following, find the domain and range. Okay, now I'm going to use knowledge that I have about these different types of functions to deduce some things here. So first, our domain. We talked about this in a previous section. We have a vertical asymptote here. So our x value cannot be negative 2/5. It can't be negative 2/5 because that would make our denominator 0. All right, so in a similar fashion, we actually have a horizontal asymptote at 3/5 because it's 3x over 5x. The ratio of those two coefficients, because the degrees are the same. 3/5 is a horizontal asymptote, so our function actually never reaches 3/5. So our domain is everything except negative 2/5, and our range is everything except 3/5. All right, part B. Because this is a square root function, to find my domain, I need to validate here that 4 minus x squared is greater than or equal to 0. That is what values I can plug in. So if I rearrange this a bit, that would be x squared is less than or equal to 4. Switching the sign because we divided by a negative there. Well, that means that x is between negative 2 and 2. Okay. So that means our domain, I'm going to go ahead and write this in interval notation, is negative 2 to 2. Now the question is, what about our y values? Well, we can sort of trace this backwards. That x being between negative 2 and 2 means that x squared is less than 4, which means 4 minus x squared is greater than or equal to 0, which means the square root of, okay, so this means the square root of 4 minus x squared is greater than or equal to 0. So our range is going to start at 0. Now, what is the maximum that it gets to? What is the maximum that it gets to? Well, I can go ahead and write this, actually, because the highest value of x is 2. Let's see, how do we want to say that? Well, I'm going to go ahead and just tell you that the range is up to 2. That's the highest point. And that is at x equals 0, that's our maximum. It's between those two zeros of negative 2 and 2. And the way that I can say that is if square root of that is, okay, let me trace this back. I want to make sure this is really clear. So this tells us that x, or that 4 minus x squared, is between 4 and 0. So squaring both sides, okay, squaring both sides, and then doing taking the end of the negative, and then subtracting the 4, that's going to be less than 4, which means that square root of 4 minus x squared is less than or equal to 2. So we're really using a lot of the same information there. So our range is between 0 to 2. In fact, this function looks like this. There's negative 2 and 2. It is actually a semicircle. Example 6. Find the domain of each of these functions. Well, for the first, we know the denominator cannot be 0, so our domain is that x cannot be equal to plus or minus 1. Simple enough. All right, second one, we can do the same thing and set the denominator equal to 0. However, it is never going to be 0, and since that's the only restriction we could possibly have, our domain is negative infinity to infinity. That's pretty simple. All right, the next one, we cannot have a square root of, or an even root really is what's going to be important there. An even root that is less than 0, so 4 minus 3x must be greater than or equal to 0, which means x is less than or equal to 4/3, which makes our domain negative infinity to 4/3, and we will include that. All right, part D, I said something about an even root just a second ago. This is a cube root, so actually our argument, what we what we have underneath the root can actually be negative. So this one has no domain restrictions. It's all real numbers. And again, you can also write all real numbers that way.